I really like the concept of turning real-life art into something you can apply to any image with just one click on a computer, and the process behind it. I made a video about string art because of this, now pretty much 2 years ago. At first this was just a small challenge, I wanted to make it without looking anything up. But I actually liked it so much I tried to add more to it. If you want to watch the video, I will link it down in the description, but I will just really quickly summarize how the algorithm works. Maybe you have seen one of those portraits made out of thread in real life or a photo of it. They are, to my knowledge, always made on some kind of circular board. Along the edges of this board there are always a specific amount of pins. The more there are, the more detailed the finished image will be. In my algorithm I have arbitrarily chosen 360. One of the pins then gets chosen at the start, and you just try to recreate an image by placing the string from the one pin to another and then another one and so on until you are finished. How this works, I'll explain in a second. But first, if you want to transform it into an algorithm, you need the pins, which are just a bunch of coordinates in a circle around the center point. Then, like in real life, you would just connect the pins with black string. To actually know the optimal next pin, so that the resulting string art actually looks like an image and not just a bunch of random black lines in a circle, you apply the following. You draw an imaginary line from the starting pin to every other pin. This will give you a bunch of lines, and you're basically asking, which line would make the biggest impact if I added it right now? You do this by calculating the average brightness of every line. And to do that, I take all the pixels that lie under that imaginary line, take their brightness, which is just the grayscale value, add them together and divide it by the amount of pixels. You want to place the string between the two pins where the line is the darkest. This will slowly approximate the original image. You can imagine it as starting with a blank white canvas and slowly making the darkest lines darker. The algorithm in the video from 2 years ago was kinda reversed, but in the end it gave the same result. As I said, this was never supposed to be the final result, but I guess I just stopped there until a few months ago. I actually wanted to make it a color image, because while black and white already looks good, it loses a lot of information which would make it impossible to imitate a painting with it. The logic is also pretty simple. You just apply the exact same algorithm for the black and white version to each color channel and then combine it again. A little simplified, a pixel is the combination of 3 values, red, green and blue. Each one of those is a color channel and on its own would just be a grayscale representation of the image. RGB is probably the most commonly used color channel in digital anything really, so I was using it as well. It works like actual light, so this is how LED lamps work as well. By combining red, green and blue you can get any color you want. So I did exactly that. I applied the algorithm for each channel individually. Instead of brightness, I would check for redness, greenness or blueness. So the algorithm would not add a black thread, but red, then green and finally blue one. And it did not work. The contours were all correct, but the colors were completely off. I really did not know why and pretty much just stopped working on it because of this after a while. Before I actually figured out why, I tried a lazy fix. I just copied the pixel's color directly onto the string. This did give me a good looking result, but I was absolutely not satisfied with that. After all, it's not how strings work, changing color every single pixel. What finally worked was changing the color mode to cyan, magenta, yellow and black, the one printers use. Why did this work but not RGB, you might ask? Unlike RGB, CYMK is subtractive. So these two are the pretty much exact opposites from each other. RGB works like an LED, combining and adding light to create its colors, whereas CYMK works like a printer, or when mixing colors for paintings, by subtracting light from a white background. So for string art, where I remove the color from the white background via the strings to approximate the original image, CMYK is perfect for that. It might be possible to do with RGB, but you'd have to do the reverse, I think. Start with a black canvas and slowly add light. And it would also not really feel like string art, as it would be more like a laser beams. After doing it with CMYK, it actually works now, but it's a bit too bright, though this fix was just accomplished by changing the strength variable. After all that, it finally works. It draws cyan, then magenta, then yellow and finally black lines, and all of them combine into the correct final color, creating this. If you enjoyed this video, consider subscribing, and thanks for watching.